Hey everybody, Miss Hannah here with a couple more examples to start off with. We're going to do a graphing case where, check it out, the first thing I notice is that the numerator's degree is exactly one higher than the denominator, and that clues us in automatically that there will be a slant asymptote. So the first example problem that I'm going to do here is all about slant asymptotes. So in order for us to find the slant asymptote, we need to begin by doing the long division. And the long division, I mean, just kind of classic. Let me get it set up here. I have that trinomial divided by x plus 2. And then this is what we know. In order to get x squared, I must have an x up top. X times x is x squared. X times 2 is 2x. You will then switch the sign and switch the sign. Those will cancel, and 7 minus 2x is 5x. Bring down, the plus 12. In order to get a 5x, it'll have to be a plus 5 up top, and then distribute. 5 times x is 5x, 5 times 2 is 10. I will change the sign of both of those, and 12 minus 2 is 12 minus 10 is 2. I'm getting ahead of myself. So this is A, this is H, and this is not the k value because it is not just a constant term, it's a binomial, and that's what tells me it is the slant. Okay, so down below here I have a spot for that. The slant asymptote is at y equals x plus 5. That is a linear function written in slope-intercept form, or y equals mx plus b. I'll start at 5, go up 1 over 1, up 1 over 1, up 1 over 1. I'm actually going to start going by 2s here just so that it'll go a little faster. Okay, so there's the slant asymptote. And a friendly reminder from in class, if there is a slant asymptote, that automatically means that there is not a horizontal asymptote, so you can just identify that as none. And then we need to figure out based on the h value, what the vertical asymptote is. So I'm going to write transformation form. The transformation form of this equation is y equals a over x minus h, then plus, I'll put the slant asymptote in parentheses over here to the side. Okay, so this right here is the slant, then I have h, then up here is a. Okay, what we learned was based on the h value, you're able to find the vertical asymptote. So because the denominator says x plus 2, the vertical asymptote is actually at negative 2. So I'll get that graphed. Okay. And then before I started making this video, I actually went ahead and found all of the coordinates for the tables. So let me just show you what I got. I ended up subbing it back into the original function, but you could also sub it into this transformation form. And notice I started both the left and the right tables with whatever the value of the asymptote is. So that's right here at negative 2. Then I went some units to the left. That's how I got these values. And then I went some units to the right. Negative 1.5, negative 1, 0, 1, 2, all those over here to the right side. So I'll just graph these and we'll make sure that the shape makes sense. Okay, so you can see the general shape of the curve here. I'm really close to the asymptote, follow it up. You're actually going to go above 0, then come back down, catch the other point, and then keep cruising really close to that slant asymptote. Based on my experience, I am anticipating that the next section will be in this quadrant of the graph, so let's see. And this shape is looking a lot like what I would anticipate. I'm going to be really close to the vertical asymptote, come down through, and then really close to the slant. Okay? So this is one example with a slant asymptote. Once again, it has that because the degree of the numerator is 1 higher than the denominator. That tells me automatically that there is a slant asymptote. Okay, stay tuned for another video. Check that out on Canvas about double vertical asymptotes. Thanks for tuning in.